One of the most common requests for video topics that I get is how to do particles in 3D. Now, you are allowed to use GameMaker's regular default 2D particle systems in 3 dimensions, but as I'm sure you can imagine, there are some limitations when you do that that makes that not really an appealing option. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about Snidr's 3D particle system, or sPart for short, or if you're a fan of the supersymmetric theory of particle physics, sPart. Guess which one I'm going to be calling it. So sPart, or sPart, is, as many things that have been made by the Snidr over the years, a 3D particle system for GameMaker. In contrast to GameMaker's built-in 2D particle system, which basically just brute forces a bunch of sprites, sPart is a shader-driven solution for 3D particles in GameMaker. And that makes it pretty fast, at least within the limitations of GameMaker's current runtime using a graphics API that's like 13 years old. So the primary reason that I haven't made a video on this until now is because up until like a week ago, sPart was hosted on the GameMaker Marketplace, and the GameMaker Marketplace is infamously not very good. And until Yo-Yo Games figures out what's going on with the Marketplace, I'm not like reasonably going to make a video expecting people to go to the Marketplace to install stuff. But it's now on GitHub, so we can now, actually do this. This is the forum thread, which has a bunch of information about sPart, and also a bunch of like pretty screenshots and GIFs and whatnot of things that you can do with it. I'll link to this in the video description. The GitHub repository can also be found in the in that forum thread. I will obviously also have this linked in the video description. I noticed that at the moment there are not any releases, which generally when you make an extension to share with people, you would just stick your releases in here. I'll ask him about that before I post this video. Anyway, you can either clone the repository and grab the sPart source code that way, or you can, presuming that there is something in the releases tab by the time you see this video, you can go over here and download whatever the most recent YYMPS is. And let's see, I'm going to close my demo project. And we can go over into wherever the folder that you may have downloaded the spark.yyMPS is. We can just drag that into the GameMaker IDE. It's going to ask us to import the asset package. I think we can do that just fine. Let's click add all. I don't believe there's any like extra included files or anything in this. So we can just click add all, and that's going to add the sPart folder to our GameMaker project. And now we can sit down and start working at 3D particles. So my sample project that I'm going to start with today is basically my usual 3D first-person camera with a like a tile layer for the floor, and I've taken out all the like 3D objects just so that there are fewer distractions. I've also gone and added SPR_part fire and SPR_part rain. These are not the most interesting sprites in the world. They do have their origin set to middle center. I will be using them to demonstrate the particles in this video. Other than that, I don't think there's anything of note in here. So I'm going to assume that you've all used GameMaker's built-in 2D particles before. If not, how? What are you doing? Stop watching this video. Go do that. They're great. They're like Play-Doh for grown-ups. And assuming that you are familiar with how GameMaker's built-in 2D particles work, sPart works on a pretty similar system of emitters, particle systems, and particle types. But the code is object-oriented rather than just relying on like a bunch of imperative functions. But if you're familiar with GameMaker's particle systems, or honestly particle systems in pretty much any engine, you should be able to follow along. There is not yet a visual 3D editor for sPart. I've been meaning to make one for like 5 years and have never gotten around to it. Maybe someday I will. So we will have to define all of our sparticles through code, unlike GameMaker's 2D particle systems, which does have a particle system editor now. But we'll work with what we have. I really do want to make a visual 3D editor for this someday. I just haven't sat down to do it. I'm going to start by opening up obj_camera and writing pretty much all of my sparticle related code in here. The way that I do things in 3D is I will generally draw the entire world through the camera object, and that way I don't have to worry about like GameMaker depth and that sort of thing. If you'd like, you could have a dedicated object just for handling like Snidr's 3D particle systems, that sort of thing, but I'm just going to use the camera. Word of advice, transparency in 3D is kind of a universally painful subject. And a lot of the time, maybe not all the time, when you do particles, you're going to be dealing with transparency because a lot of particles do have soft edges. So whatever part of your game's code is responsible for drawing 3D particles, make sure that it draws them like after everything else in the game world so that you don't get weird transparency effects. Anyway, I seem to have Arnold 2 enabled in GameMaker. I'm gonna go and just uncheck that in preferences for the time being. And that's gonna require a restart of the IDE. I love finally having an NVMe drive in my computer because it means I don't have to wait forever for GameMaker to restart. Anyway, let's go into the create event of our camera object. And I'm just gonna make that font size a tiny bit bigger. So let's start at the very beginning. So usually, if not always, when I set up 3D particles in a game project, I like to do something like rain or some other precipitation. Even if I'm not actually going to use rain or snow or whatever in the game, it's more of a sanity check for me just to make sure that I've like configured everything properly. So let me go and create a particle system, and this is going to be system rain. And as I said, this is going to copy GameMaker's system of particle systems, emitters, and types pretty closely, but it's going to be a little more object-oriented. So instead of saying like sPart system create or whatever, we're going to say new sPart system, and the sPart system constructor is going to take an array of elements. This can just be an array of one element. This is the batch size, so I'm just going to set that to 1024. By default, that's probably fine. The batch size it pertains to how much data, like how much vertex data, sPart will allocate for each particle type when it's drawn by the system. So like I alluded to earlier, sPart attempts to make particles fast by batching a bunch of vertex data together, and this batch size array is just going to control how much of that there is. You can have multiple batches so that if you end up spawning a bunch of particles and they like overflow the default batch size, it will jump into a higher bucket if you allow it to. Generally, for like sane amounts of particles, I find 1024 and 4096 as like a small and a large batch size to be fine. There's nothing stopping you from like creating an absolutely massive batch size. If you're not actually going to use an absolutely massive number of particles, it's kind of a waste. So I'm just gonna go with this. Let's see. Next, I'm going to need a let's say a particle type. So we can call this type rain, and that's going to be, again, a new sPart type. This constructor does not take any parameters, although, like GameMaker particle types, there are a whole bunch of functions which you can use pertaining to like how exactly the particle type looks and how it behaves. And we can do this by calling a bunch of methods on type rain. So we can say type rain.setSprite. This is going to mirror pretty closely GameMaker's built-in part type sprite function. We're going to want a sprite index, which is going to be SPR part rain. That's the sprite that I created. We're going to want an image speed, and I believe if you set this to 0, the system will use a random sprite index. So if your SPR part rain has like multiple different shapes, you know what? Let me do a little bit of MS Paint work with this. Hang on. It took me far longer to draw these squiggles than it really should have. Anyway, so we're gonna go and have that be SPR part rain. I will set the image speed to 0 so that it doesn't like cycle through these. Oh, there's a separate. There we go. There's a separate argument for whether or not each sparticle should spawn with a random sprite index. So we're gonna set that as its sprite. We can also say type underscore rain dot set size, and this is gonna be the size of each of these particles in like world space units. So you can set a minimum size, a maximum size, and the particles will spawn with a random size in between. Again, much like GameMaker's built-in particle systems. We have a size speed, which is if you want the size to change over time. I'm not going to do that. Size acceleration if you want the speed of the size speed to change over time. And we can define a minimum and a maximum size that we want our particles to be in case like you have your some positive size speed and you don't want it to go over a maximum size or something like that. I'm just going to set that to like 16 and 24 as my minimum and maximum. I highly encourage you to just go and play around with these. I say this whenever I talk about particles in videos. It's so much more fun to just mess around yourself than it is to watch me doing this, but I'm going to do it anyway. Let's see. I'd like to also set up a couple of other properties for these rain sprites because, like, I want them to actually look like something in the game when I run it. Let's say type rain.setLife. This is unsurprisingly going to be the amount of time before the particles expire in seconds. Min life, I can make that 1. Max life can be 1. Type rain.setSpeed. So the speed at which they move in a specific direction, which we'll get to later. I'm going to go with, I believe the ones that I chose in my sample project are 1,000 to 1,000. So again, we've got min and speed, max speed, acceleration, and jerk, which is the second derivative of speed, or the third derivative of position, or the first derivative of acceleration. I took AP Calculus in high school, and I'm determined to prove that that time wasn't wasted. I'm going to set those both to 0. So we're going to have these moving at a constant speed, no acceleration, no anything else. And lastly, type rain.setDirection. This is going to be a little different from direction in regular GameMaker particles, because in 2D you can just set like an angle on the screen on the unit circle as a direction, but in 3D it's a little more complicated than that. Our direction is going to be a vector, so if we want our particles to be moving in a certain direction, I'm going to set mine to 0, 0, -1, because I have positive z as my up direction in this example, and if a particle is going to like fall from the sky, it's going to go in the direction of 0, 0, -1, so down. We have an angle variation in case you want particles to spawn moving in like a cone shape, and we have radial. I'm going to set that to false. I don't find that the radial argument to set direction is very useful very often, but if you want to know what it does, it should be documented in all these functions should be fairly well documented. I believe there's also a PDF documentation in the forum thread if you like. So this is going to be our particle type. The last thing that I need is going to be an emitter, so I'm going to call this emitter rain, and this can be a new sPart emitter. This can belong to a particle system, again, just like GameMaker's default 2D particle systems. I really need to stop saying that. We can assign that to system rain, and we don't need any other parameters for the constructor there. If we want a to define the region where this emitter is going to spawn particles from, we can say emitter rain.setRegion. The setRegion function for sparticle emitters is a little bit different from what you might be used to. So this is going to take a 3D transformation matrix for the position and orientation, and it's going to take a separate set of 3 arguments for the size. And the reason for that is weird GameMaker reasons pertaining to how matrices are built when you say matrix build. I'm not going to get into it. That's a whole thing. Let me just say the position and rotation matrix, the position and orientation matrix maybe, is going to be matrix build. The position is going to be, and I'm going to hard code this to, let's see, if I want this to stream down from like the top of the room, I can say the position is going to be like the middle of the room. So room width divided by 2, room height divided by 2. The z coordinate can be, I'm going to just make this like 500 units of world space overhead. The rotation, I'm going to make this 0 rotation, so we're not going to like have particles streaming out in any weird direction. And I'm going to set the scale to 1. Again, you're pretty much always going to want to set the scale to 1 for the matrix that goes into the emitter regions, because we're GameMaker regions. If you want to actually set the scale of the emitter, so like how wide, tall, or deep it is, as like the volume of a dimensions of like the rectangle that the emitter takes up in screen, we can set the X scale to, in my case, room width, because I want the emitter to be as wide as the room, the Y scale to be room height, and the shape, missed an argument, the Z scale can be 1 because it can be flat. It's just going to be a flat sheet overhead. Don't really care about width or anything like that. Maybe you do. I don't know. You could set this to some other value if you want. The shape is going to be sPart shape cube. So there's a couple sPart emitter shapes. There's cube, circle, cylinder, and sphere. I'm going to just go with sPart shape cube. If you want your particles to spawn within like a spherical region or something, you can use one of the other emitter shapes. And the distribution is going to be sPart distribution, and I'm just going to go with linear. So Gaussian and inverse Gaussian. If you want your particles to spawn more cluster towards the middle of your emitter shape, you would use Gaussian. If you want them to spawn like cluster towards the edges of your particle shape, you would use inverse Gaussian. I always assume that Charles Friedrich Gauss was French because nobody ever can pronounce his name correctly, including me. But I believe he was actually German. Anyway, we're going to go with linear. And the last argument, dynamic. I'm going to set this to false. I'll get into what this does later with a different example. And lastly, we want this emitter to actually do something. So we can say emitter rain.stream. And this is going to cause this emitter to basically activate. It's going to take a particle type, so that's going to be type underscore rain. It's going to take a number of particles per step. I'm just going to set that to 200. I believe I thought that looked good when I was working out the sample project. The lifespan can be 1, so it never expires. You can kill it by either destroying the emitter, retiring the emitter, which I'll get to later, or like reconfiguring its properties. And dynamic, again, I'm going to set that to false. So this is all of the setup that we need to make rain fall down from the sky. The next thing I'm going to do is I'm going to go into the draw event. I'm going to go, again, down to the bottom. This is going to be like... I mean, there's not much happening in this draw event, right? Like, it's just the first-person camera and the floor. But let's say that, like, draw all of your 3D stuff here. I'll just leave that as a comment. And down right before we turn depth right and depth test back off, we are going to say system rain.draw. And this is going to be the function which is going to, you know, actually draw all the particles that have been spawned by the emitters that belong to a system. And the interesting thing about Snidr's 3D particle system is that it's automatically delta timed, or at least it has the option to be. So if you want to set the time increment to just like a fixed value like 1, then you can just completely ignore the time step. You can ignore delta time, whatever. More particularly, if you wanted to set it to like 1/60 or whatever the inverse frame rate of your game is, you could have your particles be like the positions and rotations and everything of your particles spawned with delta time. So frame rate independence. Delta time is a whole philosophical debate in GameMaker, which mostly means that a lot of people on the internet like to shout at each other over it. But you could also, you could just set your time increment to like a fixed value. You could set it to like 1/game get speed, game speed FPS. If you want to go all in with the delta time, you could say use the delta time built-in value divided by 1,000,000, because delta time value in GameMaker is in microseconds. The time step in microseconds. I'm gonna go with that. You can use one of the other like time step options. As long as you use it consistently in your game, it's not really that much of a problem. Let's go and run the game now. And we are going to have these raindrops falling from the sky. All right, great. We've got 3D particles. We can see that they actually have depth. So we've got particles that are spawning farther away from us being smaller than particles that spawn closer to us. We can also see that like they obey depth testing. Although, so would GameMaker's 2D particle system if used in 3D. You just wouldn't have the... you would have to jump through a lot of hoops. And I mean a lot of hoops if you wanted to have actual, like, depth in those particles. Maybe I'll talk about that someday. Who knows? Anyway, that's rain. Let's see. Do I have... Did I not set up a Git repository? Alright, apparently I didn't set up a Git repository for this project yet. So let's go and do that now. So now that we've done that, let's move on from rain to something that's a little bit more interesting. So it's always good fun creating like a fire, like a campfire or a torch or something effect using particles. That tends to be one of the things that we always go to first when we want to set up particle systems. Rain and fire, for me, are the two big things. It's kind of like modeling a chair the first time you open up a 3D modeling program. So let's go ahead and define a new sparticle system. So we can say system fire is going to be a new Spart system. Again, I'm just going to set the batch size array to 1024 4096. By the way, if you do spawn more particles than can fit inside a one of these batch sizes, it'll just create multiples. Within reason, that's not like a huge problem. It's just submitting multiple draw calls for each particle system instead of just one. It really becomes more of a problem if you have like 10 or 20 or 100 of them for like multiple particle types. But anyway, that's going to be the system for fire. Let's say the type fire is going to be a new Spart type. I'm going to want to type fire dot set sprite. I'm going to set up a bunch of parameters for a fire particle. I don't know if you really need to see me talk through all this because a lot of it's going to be the same as what we did last time, except for maybe like one at the bottom. So let me just go through this real fast. Type fire dot. Alright, so these are the parameters that I'm going to use for the fire particles. The first 5 functions that we called on this are pretty familiar. Sprite, size, light, speed, direction. Color allows you to set a blending color for the sprite. So my actual particle sprite here is just white. And we're not just going to be spawning like white, like holy flames or anything like that. We're going to be blending this with colors. So it's going to start out red. It's going to red with 100% transparency. It's going to fade to orange with half transparency, and then it's going to finally fade out to white. Fade out to yellow with 0 transparency. And if you'd like, as you can see from the code help at the bottom down here, you also have the option to set a 4th color for like a 4th stage on that transition scale. And you also have the option to set a random to choose a random color and alpha from this list instead of having it smoothly transition. And that would be the choose argument at the end. I am not going to use that in this example. I'm just going to have it transition from red to orange to yellow. And lastly, we can say set blend. Enable blending is just going to be a true or false whether or not there's any alpha blending on your particles at all. Generally, you're going to want that to be 1. Again, if there's any transparency in your sprites, I could probably set it to turn it off in the rain because these are all opaque sprites with transparency cut out. And additive blending. So if you want to use the additive blend mode, which you often do for things like fire and sometimes other things, I believe there's also a type fire.setBlend extended, which allows you to specify your own blend mode, as well as whether or not you write the particles to the Z buffer, I notice. But I'm just going to go with this for now. Something that I've taken to doing when it comes to setting the parameters of a sparticle type is calling methods on like the reference to the particle type over and over again can be a little bit cumbersome. So what you're also allowed to do in GameMaker, which is just something that's really cool about GML that I think people don't often give it credit for, is you can just say type fire with type underscore fire, and that will basically change the scope of execution to this object, and we can just skip out on calling like type fire dot a bunch of times on this, and I find that this is just a slightly more convenient and arguably readable way to write all this out. It's going to achieve the same thing, just instead of running this in the scope of obj underscore camera, calling it on the reference, calling all these methods on the reference, we're going to run this code in the scope of type fire, and we're going to call the methods on itself. Lastly, let me go and create emitter underscore fire equals new Spart emitter. The Spart type, I mean the Spart system can be system fire. We are going to want to, I'm just going to copy and paste a little bit of my code here. Let's set a region, but instead of saying that the region is going to be like centered in the room, let's just set the region to like 200, 200. The height can be, say, 50 units of world space off the ground. The width, the height, and depth, I really just need these particles to spawn from a single point. I don't really care, like, how big the emitter is. It could be a point for all I care. You could set the emitter size to 0 if you like. I think I'll just go with 1, 1, 1. Spart shape cube. We can keep it as that. Spark distribution linear. It doesn't really matter because they're all going to be spawning so close together that you won't really be able to see. And dynamic can be false. So that's just going to have these fire particles spawn at a fixed location in the room. And then we can say, oh, I also need to say emitter fire because I copied and pasted that too. Emitter fire dot stream. This is going to be, the part type is going to be type fire. The parts per step, since this is going to be concentrated in a much smaller area, I don't think I need as many as I was for the rain emitter. We can set that to 100. The lifespan, I'm going to set that to, actually, let's set this to 10 seconds so that we can see it expire. Maybe the rain puts it out or something. And dynamic, I can set that to false again. We will get to that later. Lastly, I'm just going to need to go into the draw event where these particles are drawn and say system_fire.draw, and we can use the same delta time value for the time step. So now we've got fire emanating from a single point. It's not going straight up in the air. I believe I gave it a little bit of a variation, directional variation, and after 10 seconds it does expire. So we can see that that's been extinguished by the rain or whatever. Oh, you know what? I did not set this to a random variation in direction. What I did was I set the radial parameter and set direction to true, and that, again, I don't think it's that useful most of the time. I copied that wrong from my sample project. This will have the particle's initial direction be set to like whatever their direction relative to the origin of the emitter is. I'm just gonna set that to false, and we're gonna have the fire spawn straight up in the air. All right. And then now we'll give it a little bit of random direction, like, let's say 15 degrees, and it'll spawn, like, going, like, spreading out towards the sides just a little. Alright, that's more how I wanted to make it look. Cool. And, maybe it's actually a little bit hard to see. Let me, knock the parts per step down a little bit so that you can see individual particle sprites. We can see them fading from red to orange at half transparency to, like, yellow fading out, towards the end. And, when you draw them with additive blending, like the brightnesses will add together, or at least the color channels will add together, which will make them, like, if you have a lot of particles sitting on each other, it'll make them tend towards whitish in this case, depending on what the red, green, blue color values of these parts are. So that's additive blending. I really like that when it comes to, like, fire and stuff. I also like it when it comes to, like, other things. A lot of people don't seem to be as keen on it as I am, but do whatever you want with it. Let's see. What else did I want? Oh, I also kind of wanted to, and I thought about this when I was running this. I don't think I did this in my sample project. Let's set the size speed to -1, and let's set the minimum size to 0. And that should actually have these, like, alright, this might be delta time too. Let's say, since they live for 1 second, let's say that the size speed is going to be -16, so they'll shrink by 16 units over the course of 1 second, and then they'll just, like, they'll shrink out of existence. All right, that actually looks better. I should have done that in my sample project. That looks better. Anyway, let's commit this change. So there's something else I'd like to do in this video before I end things off, and that is going to be moving emitters. So in GameMaker, you can have a moving emitter just fine. It won't do anything weird to the particles that have already spawned. But in sPart, let's see. In my sample project, I had the fire emitter, like, moving around in, like, a circle using some little sines and cosines. So let's say fire x equals 200 of our fire y equals 200 of our fire radius. Let's make this 100, and of our t, so our time step is going to be the current time divided by 1,000. So current time is a built-in GameMaker value. It keeps track of the number of milliseconds, so 1,000th of a second since your game has started. Useful if you want to do timing effects. And we can save our emitter x equals fire x plus, I'm actually going to go with a sine, just the regular sine and cosine of time, without the degree to radian conversion. And we'll multiply that by the radius of our emitter. Y equals fire y minus the sine of time times the fire radius. And then we can say emitter fire dot stream, and this will set the region. This is basically the set region function for sPart. Our part type can be type underscore fire. Our matrix can be, oh wait, set region. Set region. Our matrix can be matrix build. The position, the x position can be emitter x, y position can be emitter y. Z, I set this to what, 50 before I hard coded that. Rotation, no rotation. I guess we can rotate it later too. I'll play around with that. And uniform scale, x scale, y scale, z scale, shape. sPart shape, cube, distribution, linear, and dynamic. Again, we're going to set this to false. And this is going to cause our little blowtorch to circle around in the air. And we can see that the particles that have already been spawned are now moving with it. This might or might not be what you want to happen if you have a moving emitter, and then they fizzle after 10 seconds. That actually looked really cool. But anyway, that might or might not be what you want to happen to an emitter that is moving. And this is where the dynamic argument to the region and to the emitter properties comes in. So if I set dynamic to true, we are going to have the particles that have already been spawned stay where they are, and it's going to create basically a trail behind the torch as it moves through the air. This is probably what you want to happen most of the time, although I can definitely think of situations where you would want the opposite to happen, like the moving fire bars from Super Mario games. If you have particles emanating from something like that. But you can set the emitter dynamic argument to true. You know what? Does that override the emitter lifetime? I think it might, because it didn't fizzle. Anyway, there's a dynamic argument for the emitter as well, for the emitter stream, and I'm actually not sure why they both have this argument. If I look through the code, do they like go to the same thing? Like, do they affect the same values? Oh no, when you say dynamic stream, that I know what this is for. This is for if you like change the particle types or whatever that an emitter is streaming from. You can set this to true if you want the previous emission type to like still be there. Like if you were to hit a button and have the torch suddenly start spawning rain or something like that. If you hit the F1 key, system fire dot stream, we can have it stream like water particles, 100 per step. Let's say infinite lifespan and set dynamic to false, and then we can hit like F2 and change that back to fire or something like that. It's type rain, isn't it? I had a feeling I was gonna mess that up at some point in the video. If dynamic is set to false when I do this, really? Oh, it's emitter. I'm a little surprised I didn't do that earlier too. But if we set the if we hit F1 and have the particle switch to spawning rain, we're going to have the rain particles disappear immediately. If we switch back to fire, the fire particles are going to disappear immediately, or you know what I mean. And if we set dynamic to true, this will actually create a temporary emitter to contain the particles that have already been spawned. So that now when I hit F1, the fire particles that have already been spawned, they continue until they fade out. If I hit F2, switch back to rain, the rain particles continue to exist until they despawn. So that's what the dynamic emitter stream settings are for. Let's see. You know, I'm actually not gonna remove this. There is also something you might occasionally want: emitter fire.burst. So there is both a stream function and a burst function when it comes to particle emission. So this is going to look pretty similar. If I want to burst type underscore fire, let's really give it like a lot. Let's say 300. fire particles or something. And I can set this to true too. If we did not set our emitter to stream continuously from a location, we could instead choose to have it burst particles instead, like when an explosion happens, something like that. And if I hit, what was it, F1? Why is it continuing to emit over time? Burst is only supposed to happen once. Oh, I see. It how long it lasts is scaled based on particles per step. All right, fine. Let's scale that down a little bit. Make that a little, it's a little less ridiculous. What was it? F1? It's still lasting forever. Snidr, is that a bug? I had found a couple bugs in sPart over the years. I don't know if that's one of them or not. Anyway, the burst function does exist. You can use it. It might or might not be bugged at the present moment. Where else are we? So, I'm not aware that there is a way to just create particles, to spawn particles in without an emitter in sPart, the way that there is with GameMaker's particle system. That is sometimes something that you might want to do, but as far as I'm aware, there's no way to actually do that. It's definitely preferable to use the emitter streaming. I believe since emitter streaming is like fire and forget, it's the most optimal way to handle particle systems because you don't have to spawn and despawn stuff at random. I guess the last thing that I talk about before I end this off is when it comes to destroying emitters. Let me go back and uncomment emitter fire.stream. There are actually a pair of functions which you can use. So there's just destroy, which will destroy an emitter. So if I hit the button, really? Was I not hitting F1? All right. Was I missing the key? Oh, I saw what was happening. It was being recreated. It was effectively being reset when I reset the region. All right, let's stop that. Let's have the emitter just stay in one place. Hit the tab key, and it's going to be destroyed. You could. I thought it was calling stream again, which would cause an emitter to reactivate after it was destroyed. But I guess it works for set region too. So destroy will just have the particle emitter vanish all at once, including the particles that it spawned. If you want the particles that have already been spawned to stay there, you can call the retire method instead. And that is going to cause particles that have already been spawned to continue on their way until they fade out. There is a counterpart to that. I meant to bring this up earlier, but when you start streaming a particle system, it's going to you can see the particles that were created at the beginning, and then the particles that were created later on. The torch thing that I've got here looks like it just caught fire when the game starts, right? And it doesn't look like it was already there when we started streaming. If we wanted to have the system or the emitter act as if it had already been created, before you started looking at it, before you started the game, before you entered the room, whatever, you can call emitter.mature, emitter fire.mature, and that will basically set the particle, it'll set the lifetime of the particle system as if it had already been there emitting for a while, basically. So I think I mentioned this earlier. Sparticles are completely deterministic, whereas GameMaker's particle system basically just brute forces a bunch of sprites, keeps track of a bunch of individual positions and rotations and velocities and that sort of thing. If you look in the sPart shader, you will see a lot of what you might recognize as kinematics equations. Where's a good example of that? So there's a couple of them for position and velocity and what have you, but oh, here it is. Get position. So what sPart does is it will spawn a bunch of particles when you basically create the emitter. It will initialize a bunch of positions and texture coordinates and whatnot in the vertex buffer. And it'll basically initialize all those to 0, and it will calculate the final positions that you actually see based on the time that the particle has been alive for, based on the speed, the velocities, the accelerations, gravity, if you have gravity enabled, that sort of thing. So this is entirely deterministic. This is why streaming sparticles from emitters tends to be like the ideal way to do things in terms of both ease of use and performance. This is also why just spawning in particles on demand is kind of a whole thing, which is probably less than ideal most of the time. So the current version of GameMaker only gives us access to basically vertex and fragment shaders as far as rendering goes. More modern graphics APIs also give you these lovely things called compute shaders, and that allows you to do basically whatever you want on the GPU as long as it can be reasonably parallelized. It doesn't necessarily have to work with like vertex and fragment data. And that is how a lot of really robust particle systems in more modern game engines, and like that's even how things like really advanced simulations of the entire universe on like research facility supercomputers would be computed. And GameMaker will have access to those eventually, and I'm sure that when it does, I will have a crack at creating a 3D particle system using that. But oh, one last thing before I go. So in the same way that like you can call destroy on an emitter when you're done with it, you can also call destroy methods on the particle systems, on the sparticle systems, and on the sparticles themselves. If you're ever finished with them, these are not going to be garbage collected because they do use like vertex buffers and stuff, which are not garbage collected by GameMaker. So if you ever are finished using a particle emitter or a particle system, you should destroy it if you don't want the memory leak, if you're not planning on reusing it. Particularly emitters, if you like do a room transition and like you need to create and destroy the particle emitters that belong to objects in the room. Types and systems you can probably get away with not having to destroy, just reusing those for the duration of the game. Anyway, in the future, there is one more thing that I would like to do with sPart over here. You might have noticed it when I was looking through like the included files or the included assets, but you actually can create mesh particles, so 3D object particles. These sprites are just billboarded towards the camera, so they are they're just 2D quads that are always rotated to face the direction that the camera's facing. But sPart does have a version which will allow you to actually use a 3D object as a particle. You can see some like rubber ducks bouncing around on the GameMaker forum page about this. I can't speak to how efficient this is. Obviously, don't do this with a 3D object with a lot of geometry. It looks like it should be about as performant for, at least for small objects, as just using quads, like the regular 2D particles. And then from there, you can do a bunch of fun things like lighting and secondary particle emission, that kind of thing. I'm not going to get into that now. Probably will in a future video. It is kind of fun. So for now, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of the video. I like to post videos on weird stuff you can do in GameMaker, so if any of this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I do use sPart in that, by the way. I hope you all enjoyed that, and I will see you all later. I could set it on fire, and then we could science the fire.
See, now this is why I prefer material science over questions of subjective value.
Oh no.
Now let's turn this art history into chemistry.
Fire? I want to light it on fire.
Dang, things are getting heated in
Wait,
here.
stop. I wanted to be the one to do the fire.
Who's the one with the flamethrower?
Guys,
You or
please.
me?
What? I am the flamethrower.
I am the Senate.
Wait, okay, stop. I wasn't even trying to make a video about pictures anyway. I was gonna make a video about video games.
Special thanks to Zenjamin, Squarecrow, Spy Games, Manta Ray, GameMaker, GameArt Indie, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.